today I want to talk a bit about distributed tracing. In the previous session, a lot was talked about microservices, and for all their benefits, I think one of the major problems, not problems, a challenge that microservices face is how do you, look into a system from a holistic point. I mean, traditional tools, they kind of work, but they don't work really well when you want to see what goes on when a request crosses a service boundary, right? So tracing was envisioned, was built to solve this problem, but in our journey, we figured out that tracing is much more than just the technical problems of the platform itself. It's more of a people problem as well. Financial problem, it's a huge investment for any company and more so for a startup. So I want to go through some of these points. How do we reduce our costs? Do we really need tracing? Can traditional tools fit in? So I'll go through some of these points. I hope that any team who is trying to build a tracing platform from scratch, they can use our learnings and maybe get a head start. So our journey with tracing started back in 2020 when we were doing the migration from the monolith system to it's called the decom project. We were decomposing the monolith to the microservices. We started with Jaeger, that was the go-to project. We started with Jaeger back in, I think, July 2020, but in February of 2021, we shifted to something called Hypertrace. It's an open project, not exactly an open source project, it's an open project, and since then, the platform has seen much use and adoption. But as I said, there were some challenges along the way, and till recently we faced certain challenges. We really, to the point we really started questioning, do we really need tracing? Because it's a huge investment for any company. So let's proceed. Yeah, so for those who do not know about it, what is distributed tracing? Tracing in a very reductionist form is a better way to visualize your requests in a distributed world, right? So let's see what happens with traditional monitoring tools. You have a request coming in into one service, and then, for example, you call a downstream system, right? And the request crosses the service boundary. Let's actually take this example, right? So we have an order service, right? It communicates with 3 downstream services: the fulfillment service, the code service, and the payment service. Say you get a request, and payment service gives a 5xx, right? Now you want to, and it's just a single request. For your own curiosity, it's not an outage. You just want to figure out, what went wrong. Now, personally, I've done this. I mean, what used to be the usual course is the very first thing that comes to mind is maybe check the logs of payment service. But especially for enterprises, first, you don't always have access to logs of all the services, right? And second is, how do you correlate? Because you might be using one trace ID, and they might be using totally different new trace ID, right? Unless you have a set standard across the entire company. And for large enterprises especially, this is a bit tough to do, right? So what's the next step? I raise a ticket, right? And I set the priority as P0. The SLA is 30 minutes. The on-call gets paged in. He looks at what went wrong, and he responds. But then he's also a bit pissed because it's not an outage, it's just a single request, and you raise a P0. So not a very good practice, right? Or you can raise a low priority P2 ticket, right, and wait for a day till you get the response. So the gist of the argument here is with logs, right? It's not very clear, the request crossed your service boundary. It's not very clear what exactly happened to it, right? So tracing was built to solve this problem. It gives you a vantage point from where you can stand and have a look at your system in a more holistic and transparent fashion, right? I'm not sure if people who have worked with distributed tracing, they might have seen this diagram, maybe not, but this is called a waterfall diagram, right? Not jumping the gun here, but in a waterfall diagram, so each of these boxes, it represents a span, right? So what is a span? A span is nothing. It encapsulates a unit of work in your code. For example, you might be validating a JWT token in your code. You encapsulate it into a span. You give it some metadata, the public ID key that you use to validate, the latency. Although the latency, the systems derive it anyway from a start and end time of a span. Metadata normally are, is a map of key value pairs, but you can also attach logs. So you can have contextual logs. So span is very simply just a unit of work with some metadata attached. And then the systems, your tracing platform, what it will do is it will stitch these traces these spans together, right? So the unique thing about this is each span has the same trace ID, right? So a trace is nothing but spans grouped by trace ID. So you get a set, but then you need to have some associations among these spans, right? And that causal inference, causal relationship is established by your tracing system. So you see, so this span comes after this span, and then so all this start and end time, they are derived by the system. You don't have to do much except for the start time of this span and the end time of this span, and that is recorded by the library that you're using, right? So you see, in this system, you're not really aware, which span corresponds to which service. Of course, it will tell you that this is the service, but then it's very transparent. You can just figure out what went wrong with what span, right? So that is one step ahead of traditional monitoring tools. Then something that this diagram also tells me, for an observant engineer, he might see that, this is a staircase pattern, right? So each call is being, so each span comes after the previous span has finished, right? So it means it's a series of sequential calls. And he's making like 10 different calls to Redis. There is a scope of, I can parallelize these calls here and reduce the total time. So this kind of information, as I said, this call can be parallelized. So this visual representation tells you a lot more than just with what you would have done with traditional logs. So tracing helps in this way. So I've contrived this example, our previous example of the order service. This is how the spans might look like. I've color-coded these spans so that you know which service each span originates in. So you make a call to fulfillment. You have an entry span, exit span to fulfillment, then an entry span in fulfillment over here. This is the entry span, this is the exit span, and then you might have all these spans. So this is the main culprit span. You immediately see what went wrong. Maybe the payment gateway router, it timed out, and that is why you got a 5xx. For incident management teams, they love this feature because now earlier, they would have raised a ticket on us. We would have raised a ticket on payment. We would have waited for them to give us a response. We would have responded to the original ticket. This usually takes at least like a day, right? Now the information is readily available, and we have used phrasing quite a bit in production, and it's really useful, but with its caveats, right, that I'm going to cover. So the goals of tracing, right, and these were our goals as well. When we were doing the decom project, we wanted our MTTD or MTTR to reduce. So MTTD is basically the mean time you take to detect issues. And once you detect those issues, the mean time that you take for resolving those issues, right? So that was the primal objective. Finding bottlenecks in complex distributed applications, thanks to those waterfall diagrams and other features that have been built on top of it. Finding bottlenecks, which step is taking the most latency and all, that's quite easy. Reduce log fatigue, better productivity. Now you don't have to go through hundreds of lines of logs, right? Because spans, as I said, you can have contextual logs in spans as well, right? So you immediately know which log lines to look at. Logs are still relevant, right? Once you know something is wrong here, then you look at the logs, what exactly went wrong, but then you don't have to go through pages and pages of logs to determine that. Democratize debugging, reduce dependence on tribal knowledge, right? A good example of this is, for example, you have a shared database and it's slowing down for some reason. Now, what I would have done earlier is I would have contacted my DB and said, tell me which queries are, taking long time. Now all I have to do is, I look at all the spans that are going to that DB, right? Sort them by descending order of latency, and I see which queries are taking the most time. And better team collaboration, because I can, I have visibility into other team system as well, into other teams' systems. Now I can, intimate them of any issues and we can work together. So it kind of works, yeah. So don't really go too deep into this. I mean, any distributed tracing project, it will share some commonalities with. So this is Hypertrace's architecture, right? Hypertrace supports open standards. So in our architecture, we have a bunch of Jaeger agents running as daemon sets on nodes. Your applications, you use maybe Jaeger's library or OpenTelemetry library libraries to instrument your applications. The Jaeger agent, which is running as a daemon set, it collects all the spans. It does some batching and all. It sends them to a collector. Collector applies certain policies. You can drop spans, do some sampling, and then it pushes it to an ingestion pipeline, which in our case is Kafka. You have a bunch of transformers acting on these spans, right? So we have this span normalizer, which adds a bunch of standard fields to your spans. Then we have the raw spans grouper. One unique thing about Hypertrace is that we do the grouping at ingestion time, not the query time, right? So here we wait for like 30 seconds. The window is obviously configurable. 30 seconds for all the spans of a trace to arrive. And from now on, we no longer have spans, we have traces, right, in the pipeline. Then we have trace enricher, which does certain enrichment into these traces. Then the all views generator that creates these views in our OLAP DB is Pinot, right? So Pinot is an OLAP. So we typically need OLAP databases because users will do a lot of slicing and dicing on these traces. You know, in raw form, traces are really powerful, but then we have to enable users to be able to query them. And so we use Pinot over here, and then we have the query layer itself, right? So Hypertrace, one good thing is it's totally API driven, right? So it really helped us a lot when we wrote our alerting engine and everything because we didn't have to worry about writing database queries and all. I'll cover that later. But it has a API driven interface, right? So characteristics of any tracing platform, right? It will be near real time. That is primal, crucial, because if data is late, you're going to, I mean, these systems are typically used when something is going wrong. People rush to Hypertrace. They want to see what went wrong. If you have a lag of 30 minutes, that's of no use, right? And then if you have alerts on top of your traces, you're going to miss those alerts. We have done that. So high ingress traffic, one request can give rise to hundreds of spans. So typically, you will have a very high ingress rate. In our case, the average ingress rate is around 300K spans per second. But then we don't do any downsampling. I mean, we sample 100% of the spans. So the ingress rate in our case is 300K per second average. It peaks up to 800K per second during IPL time. So yeah, a really high ingress rate. Low QPS because the systems are not always being used. The QPS, the query per second is quite low. In our case, it's around 50 per minute. Yeah. High cardinality fields. This is where distributed tracing really shines because the metadata that you're attaching to those spans, right? It's a value of key value pairs, and values can have practically infinite cardinality. A good tracing platform will enable fast queries on these high cardinality fields. Then aggregation heavy queries, as I said, users are doing a lot of slicing and dicing on this data. So there will be a lot of aggregation heavy queries coming in from the UI because users want P99 of the duration, the error rate, and all the metrics. So we really had to use the right indices to speed up these queries. So that is one feature of it as well. I mean, there might be other features, but I think these are the most important ones. So some numbers again. Our average traffic is 300K spans per 1,000 spans per second, peaking up to 800K or a million spans per second. QPM is fairly low, around 50 per minute. Retention period is 7 days. So earlier we had a retention period of 30 days, but we brought it down to 7 days to contain costs. And because the 30 days thing wasn't very usable, I'll come to that. Daily ingestion volume, it translates to around 18 terabytes of spans per day, right, on an average. This again is with 100% sampling. So if you are doing sampling, your volumes are going to be much lower, but we sample 100% of the traces for some reasons. 100% sampling. So yeah, so let us now see some things through which we can make our system really useful and work for our users, right? Tracing is a lot of data, a lot of information, right? And if it is just sitting in your databases, you don't have really good query interfaces on top of it. It's not very useful. So we have to find ways to make tracing easy for our users to use. And one thing to remember is developers today are still warming up to the idea of tracing, right? It's not a logs like everyone has used throughout their career, right? So it's our job first to train them, to show them the value in tracing, and then make it very easy for them to use it, right? In our case, tracing is very widely used by managers, by PMs, right? By IM teams, who I mean, they are very technical, but not as technical as developers. But they're very comfortable with using tracing, and those are some of the points I'm going to cover. So, for example, the query interface, right? So this is an example of the query UI that Hypertrace has. It is called Explorer, right? And it lets you do a lot of slicing and dicing on the data. So over here, I'll give an example. We want to find the latencies of this route, right? For each of our merchants, right? So we wanted latencies to be grouped by the merchants, right? So if you look at the query, the predicates that have been written, so we have the service name. So Hypertrace has an entity-driven model. So we have service names, endpoint names, backends, right? These are all treated as first-class searchable fields, right? So Hypertrace knows what a service name is or what a endpoint name is, right? Because it is deriving all of this information in the ingestion pipeline, right, from your traces. So we specify the service name, it's API prod. We specify the endpoint name, it is V1 payments create. I want only high latency traces, so I specify duration as greater than 500 milliseconds. And I want only the traces that were successful, so I do that. I specify the key on which I want to do the group by, right? So over here, if you can look, so I group by tags. The tag key is merchant ID, right? I specify the metric I want, the aggregation I want, and I have the data over here, right? So I don't see any reason why anyone won't be able to use this feature, because I mean, this makes it really easy to query Hypertrace, right? So the power of Explorer combined with its ease of use, it really gave us much traction. When we started out with Hypertrace, we had to do a lot of evangelization. So this is what we used to demonstrate to users, and they used to love it. And not just users, even IM teams just love this feature. So second thing we built is custom dashboards, right? So for instance, if I want to monitor a certain merchant, right, a certain high-value merchant, I want to, it's the IPLCs, and I want to see the route latency and what load I'm getting. I can create custom dashboards. Now, why is it so special here, right? Custom dashboards, a lot of tools support it. But let's see, so let's see merchant ID. Merchant ID is a very high cardinality field, right? And creating dashboards on something, say Grafana, right, that is not advisable. And if you do this on your logging platform, because it has to be updated in real time, it mostly goes into the continuous tier of data, which is very expensive. So yeah, I mean, especially in the context of our company, we use continuous tier only where it was absolutely needed, right? So Hypertrace, it fit in really well over here. You could create dashboards for any high cardinality field, doesn't matter. And the best thing is, right now it's work in progress. We are working on enabling the users to set up alerts right from the UI, right? So no more DSLs and query languages, right? So this was also much loved and gave us a lot of traction, right? Something we built ourselves is deployment markers, right? So during our FGDs, we used to conduct these weekly focus group discussions. One of the most requested features was, I have done a deployment, how stable is my system after the deployment, right? And we had all of this information because Hypertrace is tracking the service versions and everything. So we already had this information. We had to get it out to the UI. So we built a deployment marker, and as you see over here, right? So the latency, for instance, has spiked, right, after the deployment. So this again was the SRE teams and the developers themselves, they were quite enthusiastic about it. So the gist of the argument here is don't just trace data for all its power. It's worthless if your users are not able to query it, right? So give them nice query interfaces, build nice features on top of it, but don't build vanity features, right? So those features have to be data driven. So personally, we were doing a lot of FGDs, office hours, and all of these came up during those discussions, right? Yeah, coming to my point of evangelization, not all of us love to do it, but as a platform team, I think we can't really escape evangelization, and especially if it's something we are building totally new. So as I said, developers are still warming up to the idea of tracing, right? And it is our job to show them its value and to make it easy for them to use, right? So you need evangelists here, and each developer needs to be evangelist. It's not like you have a product manager and it's their job. You really have to get into your customer's shoes and see what they exactly want, right? So some tips, you can do weekly focus group discussions, office hours, training. Training is crucial. Otherwise, you can expect thousands of Slack pings a day. That this is not working or that is not working. So we had recorded videos, but then with all the new features, we had to re-record it. And so, but we did a lot of training, and that really helped. And not only for developers, but also for managers, right? Because managers or PMs, Hypertrace can be indispensable to them as well, right? SRE teams, another feature that SRE teams, they used to love is the service map, right? Because Hypertrace gives you, I don't have a picture of it, Hypertrace gives you a very detailed service map, right? Jaeger does that too, but Jaeger doesn't give you a lot of metrics. So with service maps, you can find all the error between any two services. You can figure out what the error rate is, or what the latency between them is, right? We used to get into almost every incident that was going on in the organization, and we used to, if someone is stuck, we used to help them out with Hypertrace, and the experience was generally very positive. With Hypertrace, we were able to answer queries very quickly. So yeah, this will be a part of the process. So not just tracing will give you a lot of nice engineering problems, but also some people problems that you have to worry about. Another way to ensure that you are bringing in value with tracing is ensuring that you are ingesting the right quality, good quality traces. Because in our experience, as Jamie said in the previous talk as well, we are mostly a reactive species. People don't really worry about how good their instrumentation is. They worry about it only when something goes wrong and they figure out they don't have that data in Hypertrace. So they see tracing as a panacea to it will just solve all their problems, but then they are left disappointed because they don't have something that they anticipated in the system, right? So till some quarters back, this feedback to teams used to be qualitative, right? We used to just go, okay, boss, look, you are logging something confidential, and you shouldn't do this, and it used to take its own. They used to take their own sweet time to fix it. So we figured out we had to make it quantitative, right? And we had to make it actionable, right? Give some sort of reinforcement. So we saw a lot of things being logged, right? Hashes. No one ever queries on hashes, right? But they were just dumping it. Public keys, right? They were being dumped. Public keys. I mean, okay. I mean, high cardinality. Tracing is good with high cardinality tags, but then you're not only increasing the storage cost, but also the system's performance, right? We saw some PCI data being logged as well. I mean, quite rare, but it used to happen, right? So this was absolutely crucial to kind of give them actionable feedback, right? So some stats. So 50% of the tags that were being dumped into Hypertrace, they were just there. They were never queried from, right? 10% of the services, they were logging some sort of sensitive info, right? And a lot of defensive dumping would go on. They would just dump everything, request payloads, response payloads, right? In hopes that if something goes wrong, they have the data. But 99% of the time, they're not even querying it. So extremely bad practice, right? So we measure QoI and now on 3 fronts. So we have quality, completeness, and security, right? So quality refers to the quality of the existing metadata in your spans or traces, right? I'm using, for an example of quality is how long your tags are, right? If 50% of the tags in your spans, they are more than 500 characters in length, I mean, that indicates, you are just mindlessly dumping them, right? Or what is the depth of your traces? So if your traces are containing, like we have had examples in which traces were like 2,000 spans long, and that was just, again, not very helpful. So we have certain parameters on, or what noisy fields you are dumping in. So for example, we have a static list right now, hashes, public keys, everything, right? If you dump these, we're pretty sure, you're never going to query on these, and you're just dumping it unnecessarily, right? So then we measure it on completeness. So how complete the information in your spans or traces is, right? A good example is every span to a relational database, right? It should contain the corresponding database statement. Why have we mandated it? because it makes it very easy for us to figure out the slow query logs, right? So if we define an invariant that every span to a DB will have a corresponding DB.statement tag, life becomes easier, right? So we validate your spans, your traces on these fronts as well. And then security. So security, you shouldn't be logging any PCI or PI information. So we do a lot of redaction early in the pipeline at the collector layer, but then even after redaction, if you are dumping, we make sure that we tell you about it, right? Because it's not 100% foolproof anyway. So this is how the UI looks right? It was inspired by, I mean, as a disclaimer, it was inspired by Lightstep's QI framework, for example, on the screen, you can see your score is 85, right? The overall score is a cumulative score of all 3 sub-scores. We also calculate it at an organization level, so how well the organization is doing, and also at a BU level, although it's not visible here. So each business unit, so for example, platform, if it's scoring 90 on the QI front and you are at 85, it means that you are a bit, you need to improve. You can drill down into any of these cards. For example, this is quality. These are the attributes. These are the checks that we have right now. So no noisy attributes, no empty attributes. If you are dumping empty tags, I mean that is just useless, right? Limited attributes volume. Your span should have a reasonable number of should have a reasonable amount of metadata, right? If you are having like 200 tags in your spans, again we are going to mark it. You can go through some of these example traces to see some examples, right? And this is a simple Spark job, just to tell you a bit about how we do it. So it's a simple Spark job. It runs every day. It consumes a sample of like 10, 50 million traces. It groups them by service IDs and does all of these checks. It's pretty basic, but yeah, it's good enough. Make it actionable, as we said, this was one of the goals. We have to make it actionable. So what we started doing is every quarter we started publishing a newsletter in which we used to name the best and the worst performers, right? And especially on security front, because this was driven by the security team. So they get the names and they make sure that it's a part of their OKRs. So we saw these scores improve over quarters, right? So yeah, with QOI, top-down reinforcement is the only thing that we found out worked. Coming to integration, this is another area you are going to face some challenges because with legacy applications especially, right, no one wants to instrument it first to start with, and then once they have instrumented it, no one wants to touch it, no matter how much feedback you give to them, right? Our code base is mostly PHP and Golang, right? We also have Java and Scala here and there, but mostly we work with these. So for PHP, we went with a fork of open sensors because there were some bugs in the original original project. So we fixed some of those bugs, and so we have a fork of open sensors. Open sensors, by the way, it has merged with open tracing now to form open telemetry. So open telemetry is the only thing that kind of is going ahead now. We use Jaeger agent for Golang. We wrote a standard tracing library, a tracing package for Golang applications, which follows a bit of convention over configuration approach, right? So it helped us a lot to maintain the quality, right? So for example, for any span to Kafka, it's gonna tag it with whether it's a producer or the consumer, right? So it adds a standard set of tags and everything, so it makes our life easier as well, makes debugging it if someone says that this span is not coming, we have some idea where to look at. So the tracing package helped as well. We remove bottlenecks, right? So when we started out, all the code reviews for instrumentation, they had to be done by us because people was just not confident. So we ensured that we do sufficient training of them. We wrote detailed FAQs that if your spans are not arriving in Hypertrace, these are the places you should look at, right? Start right from the instrumentation, check if Jaeger agent is running on the nodes, and we gave them some debugging steps. So we removed these bottlenecks with training sessions and FAQs, and integration now is mostly a solved problem. I mean, we still have to help people, but they don't really need any hand holding, right? Coming to alerts, right? As I said, alerts on traces can be very powerful for two reasons. One is the amount of information you have in your traces, right? It's a gold mine, right? And second is for high cardinality tags, alerts work for us really well. We have a lot of P0 alerts on our system now for specific merchants, specific routes that were migrated from our logging system to Hypertrace, right? But then if you want P0 alerts on a system, you have to treat your system as a P0 system, right? So you ensure that the data lag is not exceeding, say, 5 or 10 minutes. If you miss any alerts, which we did initially, it really raises some questions whether, we can trust this system. Because it's a new system, people are still warming up to it. This is the first question, are we missing alerts? They generally don't ask it of say, Prometheus or the logging platform, right? So why we built alerting and did not go with, in fact, Hypertrace has its own native alerting solution as well. We built our own because we wanted to keep the learning curve essentially zero, right? We figured out that if we have to migrate alerts, we have to increase the adoption of this. We have to keep the learning curve to zero, right? If I ask my users to write your alerts the corresponding database query, right, which some solutions they do, right? We figured out that it's not going to work, right? So we wanted to keep the DSL as simple as possible, and we already had an alerting framework in place, right? We have integration with PagerDuty and everything. We wanted to just reuse that alerting framework as much as possible. So we wrote our own alerting service, right? Regarding the query language, I showed you the Explorer example, right? We wanted to keep the alert expression as close to the query UI as possible, right? So today, I mean, if you look at an alert today, right, this is how it looks like. And this is very similar to how you write the DSL for alerts for Alert Manager, right? Just the alert expression is different. Everything else remains the same. And if you look at the alert expression, it is exactly similar to how you would have written this query on the Explorer, right? So essentially, I mean, users were like, they already knew how to write alerts. I mean, it was just all the effort then went into migration, right? So we sat down with them, we migrated their alerts, but we didn't have to teach them any new query language, right? Had I asked them to write query language for Pinot, I mean, this would never have taken off. Coming to the cost front, because yeah, everything will boil down to cost at some point, especially nowadays, right? So data retention, right? So data retention is a fundamental problem. How long do we retain our traces for? I told you we went till the extent of retaining them for 30 days. It's not uncommon for people to ask them why my traces from 2 months back are missing. You might have to do it for compliance, even for RCAs, right? There was an issue. You are writing an RCA maybe 2 weeks down the line, and you want to see data in Hypertrace for that issue. So yeah, data retention is a fundamental problem to solve here, right? But the good news is it's getting a good amount of retention period. It's not that expensive. You just have to do a bit of analysis. We did some analysis on our query patterns. We figured out that most of our queries they lay in the last 1 hour, right? So yeah, you can see, I mean, this is almost touching 80%. The fraction of calls. So almost 80% of the calls, they were going in the last 1 hour. And this data is from like 2 years back. And now these patterns would have changed a bit, but the trend would remain the same, right? So this gives us a surface area to kind of exploit, to optimize on, because, as per the maxim, you optimize the common path first. So we optimize for 1 hour, right? So there are two things to optimize here. One is cost and one for performance, right? For cost, I know that, if I just retain data for 1 hour, 80% of my users are happy, right? Now I have to worry about the remaining 20%, right? And the second thing is performance. I now have to optimize my database because querying these traces fast is very important. Now I have to optimize my calls only for the past 1 hour, right? It's okay if my calls are a bit slow for data older than 1 hour, right? So again, this chart, it shows how query frequency on data, it goes down as data ages. At some point, you will only need that data for compliance or as I said, RCS. So these asymmetrical query patterns, they give us some chance to do cost savings on storage. how we, our journey starts. So first we were storing everything on SSD, 7 days worth of retention, which was quite expensive, with 80 TB of data per day, 18 TB. We went with something. So Pinot supports hybrid storage natively. It will let you tag a set of servers, and the controller will move around data partitions as and when they age, right? So we went with SSDs and HDDs. So for 1 day retention, we were storing it on SSDs, and the remaining data, it would go to hard drives. But we figured out, why do we really need this 6 days data? We can, as well store it on S3, right? But Pinot open source does not support native S3 storage, right? So we went with Startree for that. So Startree gives you managed Pinot, and in their own fork of Pinot, they support it natively. So once we moved to Startree, the storage costs, they were reduced drastically thanks to the S3 thing, right? Because we don't have to write any special query layer now to query from S3. Pinot is supporting that natively, right? So we could achieve almost a 75% reduction in storage costs. So right now we are on EBS GP3 plus S3, right? Yeah, our journey. So we started with 7 days on SSDs, which was obviously the most expensive, but also the most performant. Then 7 days on SSDs, 1 month on S3. This was a very terse solution for the worst case, because we had a Spark job that used to consume data from the ingestion pipeline, and it would create those SQL tables on S3, right? And they used to be queried through Trino. So you have to write SQL queries. There's no way around it. We built that solution just for the worst case if you really need that data. So here you have it in raw form. Maybe you won't be able to query it as good, but then the data is there, right? It was the least performant, very tough solution. Finally, we went with 1 day retention on SSD, and it's not 30 days right now, it's 7 days. 6 days on S3 with Startree. So right now we are at a sweet spot. Yeah, at some point you will want to sample your spans, right? Although we're not doing it, but sampling, it reduces your ingestion costs and storage costs, right? And anyway, sampling makes sense because most of your spans, they are uninteresting, right? Like 90% of your calls are ending up in 2xx, right? Why do you even need that data, right? To start with, you can start sampling at the collector, and which is really easy because you can just analyze some endpoints, for instance, health endpoints or ping endpoints, right? They're never queried and they send a lot of traffic. So you can just drop all of these spans right at the collector. We could save around 30K per second of bandwidth, if I may, by doing this. Then you can, to start sampling, you can start with a head-based sampling strategy in which you make a decision whether to sample a trace right when the very first span of that trace is created, right? You make a decision and you propagate it down to all the children's spans across service boundaries, right? This is done through context propagation. This is important because if you just sample some spans of a trace and you do not sample some spans, you will see broken traces on the UI, right? So you need to make sure that you either sample all of them or you don't sample anything, right? Head-based, so you make a decision. Now this decision can be based on a chance for probabilistic sampling, or you can do rate limiting sampling as well. For instance, I want to keep my span rate, a limit on my span rate, and the system ensures that you do that. So it does that. So head-based, you will, it's easy to implement because it can be done straight in the libraries, right? But then you lose a lot of interesting traces as well. So if you want to avoid that, you can go with a tail-based sampling approach. With a tail-based sampling approach, you wait for all the traces to be collected, and then based on the properties of that trace, whether it's a erroneous trace or not, you make a sampling decision. But then it becomes a bit complicated to deploy because the OTel collector now becomes, if you're doing it at the collector level, the collector becomes stateful, right? Because now all spans for a particular trace, they have to go to the same collector instance, right? So a bit difficult to deploy. Now, why we don't do sampling is two reasons. One is hypertrace is also used very extensively for metrics, right? And we haven't really figured out if we start dropping spans or traces, how they will impact the metrics. We have a lot of P0 alerts now, so it's quite a critical system. although we have some documents running on sampling, for these basic reasons, we haven't really, we are sampling everything right now. We are paying the cost for it, 18 terabytes of spans per day, but we will soon come up with something. But yeah, this was the basic reason. We don't want to mess up the metrics, right? Yeah. So, at some point, everyone will face this question whether you are going with in-house or SaaS, right? And we were facing this question till quite recently. So, well, I mean, if you're planning to build a system, just keep some vagaries of it in mind, right? Ops plus development will need a proper platform team, and managing a platform team, from what my manager tells me, it's not easy, right? So, it will come with its own set of challenges, people problems, right? You should be ready to deal with that. Takes time to build expertise. We have been building on Hypertrace and Pinot, for over 2 years now. We built some expertise on it, the entire team, but it takes some time. So if it's a new team starting out and you throw a problem at them, it's going to take them some time to figure things out, right? And it's a long-term investment. You should be ready for it, right? You can't be like 6 months down the line, I want to migrate, I want to switch, I want to go with the SaaS system. Now you have to migrate all your alerts. It can get quite expensive. Migration is a big headache. Well, if you want to buy it, right, consider your scale, not just the scale that you have today, but 1 or 2 years down the line. Because at large enough scales, especially at our scales, with a per GB or per span pricing model, even a linear increase in scale can increase your cost exponentially, and the returns really diminish. So SaaS providers, they can get really expensive at large scale. So again, you don't want to be reevaluating your options 1 year down the line. That's going to be expensive. So keep that in mind as well. We are at a hybrid approach. So we manage Hypertrace ourselves. But we have given the, we use Startree to manage Pinot. Some benefits of a Startree were first, the native S3 tiering that reduced our costs. There was some ops load on Pinot that was offloaded to them as well. So the team could totally focus now on Hypertrace development. So we kind of got the best of both worlds. And the TCO, even with the licensing fees and everything, it dropped down to around 10 or 15%. So the total cost of ownership actually came down. So it made sense for us. We have to be able to quantify the value of a tracing platform. It's a new platform. When times are good, you'll hear a lot of places, but in testing times, it's often the very first on the chopping block. A lot of questions will be raised. Do we really need this? So it's important to be able to quantify its value, but at the same time, it's non-trivial, right? When an incident is going on, you're using n different tools to debug your issues. How do you even measure the MTTD or MTTR, right? You can't just ask the people, how was Hypertrace useful, or how long did you use Hypertrace for, right? But try to track the MTTD, MTTR. One way to do it is work with the IM teams to see how the incident was debugged and was Hypertrace useful. Get into calls with IM, the ongoing incident calls. Help the teams out. Track your adoption numbers every quarter, right? So so that you have some rough idea about Hypertrace is really bringing value to our people, right? And finally, work with the community. Tracing, in fact, whole of observability today, it's mostly OSS driven, and it has a very active community. We work very closely with Hypertrace and Pinot folks. A lot of challenging problems were solved along with them, right? A very naughty problem was, the raw span grouper component, which is stateful, right? We wanted to group spans that were like 2,000 traces that were 2,000 spans long. That was really increasing the memory pressure. So Hypertrace team really helped us out. Pre-aggregations with Pinot team really helped us out. So work with the community. That will make the journey much more enjoyable. With this I am done. Thank you.